Hello everyone and welcome to this Introduction to Computer Science course. This course is designed to guide learners step by step through the fundamentals of computing. While I've designed it originally for the University of the People student in mind. It is open to anyone curious about technology, whether you are starting from scratch or simply want to strengthen your understanding. You will find this course accessible, you find it practical, you find it engaging, right? So, yes, if you're a University of the People student, this course is for you. I'm coming to go through the computer science course, all of them for you guys. This is how I also want to contribute to the UO people community, right? So, yes, let's begin the journey into the world of computers together. Stay with me. Let's go. So, right, I want you to take a moment and think about something for me. You know, the the phone in your hand right now, or the laptop you use, or the internet you use every day, right? All of these things did not just appear overnight, right? So there was a time when computers didn't even exist, right? And the idea of having one in every home sounded impossible. So the question will be, how did we get from no computers at all to a world completely driven by technology, right? So in this course, we'll go, we'll be going through it step by step. You know, you go from no computers at all, how everything started from history. We will start from there to a world completely driven by technology. We go through everything. It will be beginner friendly. I will make sure understanding is clear for you guys. You know what computer science really is, right, and how it all started, right? Okay, so let's move forward. Let's look at our learning objectives. So by the end of this course, as a student, you will be able to one to demonstrate the basic foundational knowledge of computer systems. The two is identify and apply basic concept of number systems, Boolean algebra, and logic gates. 3. Explain the working fundamentals of operating system, computer networks, security, and databases. So the fourth one, you will describe a programming paradigm, problems, and identify and correct syntax, right? And then the last one is discuss emerging trends in the field of computing. So by the end of the whole course, as a student, this is what you should be able to know, right? These are objectives, and then the outcome of the course, right? So the unit one, the introduction to computer systems. Under the introduction to computer systems, let's look at some of the things, our objectives here. You compare and contrast different computer systems, architectures, and their implications on performance. And two is explain the concept of the stored program concept and then its importance in modern computing. And then explain the role of secondary storage devices in terms of data persistence, capacity, and access speed. And the fourth one is differentiate between system software, application software, and then embedded software and their roles in the what in computing environment. Right. So concepts and computer fundamentals. So as we said, we will go through from the history introduction. We will look into data processing and information data processing and information. You look into defining the computer system, computer classification, block diagram, hardware versus software, computer memory, and then storage devices. That's the direct access storage devices, and then the sequential access storage devices. Right. So we start this unit. Let's start by one of the most important questions. That is what is computer science? So when we say what is computer science, so what exactly it is, right? Sorry. So computer science, often called CS, is the study of computing, right? So you might be asking, so what is computing, right? So computing is simply the process of using computers to solve problems, right? By receiving input and then processing them and all those things, right? So you are using a computer to solve problems. So when we say computer science, we are not just talking about the physical computer you see in front of you, right? Uh, we are talking about everything that makes a computer work. So from software running inside it to how it processes information and everything. So to communication, how the system communicate with other systems across the internet, right? So this it includes computers, right? So it includes computers, the internet, and then information processing. So for example, let's say you open a website, right? Send a message or watch a video online. There are multiple systems working together behind the scenes, right? So let's say your device sends a request, like who is Mr. Beast or who is the president of this country or whatever. Servers will process that request and then data is transferred, right? And then you will see the result as on your screen as an output, right? So let's go to our browser and look into that. So we open our browser. Uh, so we search, example, we search like who, or let's say we search for University of the People, University of the People. Then you click on enter. So this one you are doing, this is the inputting you are doing. So you click on enter, right? You see servers, it will process, right? You see it's processing. So things are working behind the scene that you are not seeing, right? So there are multiple systems working together, right? You go into that. This is just the beginning. You understand it further how things are working behind the scene further when we get to more details in the course, right? So this a request has been sent before receiving this info on our screen as an output, right? And so all these things involved, this entire process is part of computer science, right? So to understand it better, right? So think of computer science like this. Every system follows a simple pattern, right? And what are the patterns? Let's get to our lesson. So it follows the input, that's you entering something into the search bar, and then it will process it, right? And then you get your output. So when you type on your keyboard and everything, it will process what you type and then it displays it as an output on your screen, right? That's computing. That's basically computing in its simplest form. So yeah, so computer science is not just about using computer. It's about or like browsing or typing, whatever. It's about understanding what is happening behind the scene, right? And then as we get along in the course, you guys will understand it further. You know what is happening, more details into it. So, and then learning how to design systems. When it comes to computer science, you have to learn how to design systems that can solve problems, right? We will go into details on all of these things, right, later. So we will start from how everything started, right? Good. So we are coming to start from the history, how everything started, before we go into details about computer science, right? You need to understand where it all started, right? There was a time when computer didn't exist at all, so we have to understand everything, every process uh, of it. So computer science from early tools to modern technology. So there was a time, as I said, there was a time when computers didn't exist at all. Every calculation, every record, every process was done manually by humans, right? So imagine you trying to calculate large numbers without a software or a calculator, right? Okay. Okay. So you trying to, so as I said, without a calculator, you trying to solve all these things or without a calculator or software as we use today, right? To solve this problem in the early days, you know, the early societies created tools like the abacus. This is the one on your screen. So this is the abacus. Created these tools for this abacus help people count, add, and keep track of numbers. Right. It may look simple today. This abacus may look simple today, but at that time it was a powerful computing tool. Right. Okay. Right. So, but tools like the abacus had limitations. They had limitations. They require human effort, and then calculations could still be slow and error prone. So over time, better number systems were developed, right? So that's a new number system. So better number systems uh, were developed, like the one we use today, which includes zero and place values, right? So the zero and then the place values. This made calculations easier and more flexible, right? This has made calculation easier and more flexible for us. Okay. So as things kept changing, something very important emerged: the idea of solving problems step by step, right? So these step by step instructions are what we call algorithms. Even back then, people were already thinking like programmers. They just didn't have computers yet. So when it comes to the physical world, think about cooking for like this. A recipe tells you what ingredients to use, what steps to follow, and how to get the final dish right. That's an algorithm. Let's look at an example. Uh, think about cooking for a second. Let's say you want to boil pasta, right? You don't just guess what to do. You follow steps, and that steps must be precise, right? First, you pour about 2 liters of water into a pot. You heat until it boils, and then you add the pasta. Wait a few minutes and finally drain and serve. That step by step process, that series of instructions, that process that you've gone through from start to finish, that's exactly what an algorithm is, right? So when it comes to an algorithm, it's just there's instructions, and then those instructions, you have to be precise with it, right? So you deciding that, okay, when I wake up in the morning, I'll brush my teeth, I'll wash my face, I'll do this before I'll go to here, I'll do this before I'll do this. So those instructions that you've set for yourself, in the physical world, those ones are just also an algorithm that, oh, you do this before you do this, you do this before you do this, right? You go to work, when you're back from work, you go and do this. So you set instruction for yourself that these are what you do. So that's basically an algorithm, right? So when it comes to the world of technology, you want to you set the computer to do this. When this happens, you should do this, right? So those are it's just the instructions, right? The instructions you've set the computer to follow. So whenever you hear the word algorithm, it's just instructions, step by step instructions, right? So every algorithm follows a simple idea. You start with an input, you follow a series of steps, and produce an output. So whenever you hear the word algorithm, think of it as a step by step process for solving a problem, right? As problems were getting more and more complex, people started looking for ways to make calculations faster and reduce human errors. So in the 1600s, a mathematician named John Napier introduced logarithms, a simple but powerful method that made complex calculations much easier, right? So this idea was a big step forward for them because it allowed scientists and engineers to solve problems much faster. You understand? Then came the idea of machines that could calculate automatically, right? So what's that? The earliest computers weren't electronic machines. They were human beings, and then humans had a problem, and then people get exhausted, people lose concentration and stuff. People slip up after hours of repeating the same calculation and over again. Eventually, somebody writes the wrong number. A tiny mistake on paper suddenly becomes a massive mistake in the real world. This was the crisis Charles Babbage wanted to solve in the 19th century. So Babbage was a mathematician from Britain, known for being uh, brilliant, right? He was known for being brilliant. He couldn't stand inaccurate mathematical tables. So, scientists, engineers, navigators, like they all depend on them, yet errors kept appearing everywhere. The more he worked with those tables, the more frustrated he became, right? So, Babbage came up with an idea. What if calculation could be handled by a machine instead of a person, right? So, in the 1820s, he started designing a mechanical device known as the different engine, using carefully connected metal gears, right? The machine would automatically compute complex mathematical results, and then right, it could even print the answers directly onto paper, reducing the chance of human error on paper. The invention was extraordinary, but in reality, building it became a disaster, right? Building this machine was a kind of a difficult task for them, but the machine was expensive. The design kept changing, progress slowed down, right? So eventually, financial support disappeared, and then the machine was never fully completed while Babbage was alive. But during that struggle, He began thinking about something even bigger, right? Babbage wasn't thinking small anymore. After the difference engine, his imagination moved toward something far more advanced. He called this new concept the analytical engine, right? And unlike his earlier machine, this one wasn't limited to a single calculation. It was meant to solve different kinds of problems depending on the instructions it received. That idea was revolutionary for the 1800s. So the machine was designed with separate sections, each responsible for a different task. Right. One section will store information temporarily to the machine so the machine could use it later instead of starting over every time. Today, we know that as memory, right? What he was trying to do, today we know it as memory. So another section that he included he included was a section where we will store informations, uh, will handle what do you call it? A section that will handle the actual calculation and manipulate the stored numbers. And then that one too, in modern computers, that role belongs to the processor, right? To feed instructions into the machine, Babbage planned to use a punch cards. These cards already existed in the textile industry, where weaving machines used patterns of holes to automate complicated fabrics designs, right? So Babbage saw something bigger in that idea. He was like, if holes on cards could control weaving patterns, why couldn't they control calculations too? So instead of manual guiding every steps, right? Uh, the machine could follow instructions automatically. That was his plan. Now, what if you have to guide every step and all those things? The machine should rather follow instructions automatically. But the truly remarkable part was how flexible the analytical engine was supposed to be, right? It wouldn't just follow commands in a straight line. The machine could repeat actions when needed. You see, the man is very brilliant, right? He has the idea of doing things to reduce human error. Very, very brilliant. Uh, you see, the machine can react differently depending on result and then change what it did while running. These are the exact foundation modern programming still relies on today. You understand? Which means that long how do you call it? Which means long before electronics computer existed, right? Charles Babbage was already imagining a machine that behaved like a programmable computer. The technology of his time simply wasn't ready for it. You know, they were not having those all kind of electronic devices to do all these kind of things. But he has the idea, right? He has the idea. He has drawn the architecture down. Charles Babbage was already imagining a machine that behaved like a programmable computer. But you see, those there are time the machines they have they can't do all of these things. So the analytical engine was never fully built, sadly, right? Because we were not having all the tools. But the concept behind it were decades ahead of the world around him. And eventually those ideas will reshape human history. Right. The man is very brilliant. He's very brilliant. So in the 1800s, still in the 1800s, a woman named Ada Lovelace became deeply interested in Charles Babbage mechanical computer design. So, who is Charles Ada? Ada born. So Ada Lovelace. She was born Ada Byron. She was the daughter of the famous poet Lord Byron. But while her father became known for poetry, Ada became fascinated by mathematics and machines. At a time when people truly understood Babbage's idea, right? Ada saw something remarkable in them. In the in the 1843, she worked on translating a paper written by an Italian mathematician about the analytical engine. But the translation wasn't the most important part. It was the notes she added afterward. Right. Her note became far longer than the original paper itself. So uh, inside the note, she described a detailed set of instructions designed for the machine to follow step by step. Right. Today, many historians consider that to be the first computer program ever written, which is why Ada Lovelace is often called the world's first computer programmer. But what made her truly ahead of her time wasn't just the program she wrote, it was the way she understood the machine itself. You know, most people saw the analytical engine as a device for working with numbers, right? Ada saw something much bigger. She realized that if the information could be represented using symbols, and then the machine could theoretically manipulate anything. This woman is very brilliant, right? Anything like what do you call it? Numbers, words, music, patterns. To her, the machine wasn't simply doing arithmetic; it was following rules to process information. Right. That single idea will eventually become the foundation of modern computing. But neither Ada Lovelace nor Charles Babbage lived to see their vision fully built. Right, the technology of the 1800s simply wasn't advanced enough to bring all these visions to reality. The machinery required what do you call it, an incredible level of precision that manufacturing at that time struggled to achieve that precision. You know, so the analytical engine remained mostly trapped on paper. The idea, you know, all these ideas were kind of theoretical on paper. Inside sketches, they were, and then note, and then what, and finished. They did prototype, which was not even completed, right? The ideas were left with unfinished prototype. Eventually, the world moved on, and for a while, uh, these ideas were almost forgotten. You know, yeah. So machines were developed that could process data using punch cards, marking the beginning of automated data handling. Right. So if you can see here, this is an image of the punch card. Yeah, you can see it. Right. And then by the 1940s, the first row computers were built. They were very large and then expensive, and used mainly for research and military purposes. That was in the 1940s, right? And then in the 1950s, the digital computers changed everything. They became faster, more reliable, and more powerful, right? So, this is when computer science began to emerge as a field of study instead of human beings doing calculations, right? Computers started solving problems, and this completely changed how we approach technology, right? Now, now with all that background, we can properly understand what computer science really is. Computer science is the study of how computers work and how we use algorithms to solve problems, right? It was it, it, computer science is what powers everything around us, right? From apps and websites to communication and business systems, right? And the most interesting part of this idea were developed decades ago, but they still shape the technology we use today. So, uh, to truly understand computer science, we must understand where it came from, right? We need to understand where it came from. Here is something interesting. In the past, using a computer was not easy at all. It requires time, training, and sometimes even professional help just to perform basic operation, right? So early computer systems were not designed for everyday people. You had to type commands, you remember instructions, and understand technical details, right? So only trained professionals could really use them effectively. But everything changed with the introduction of something called the graphical user interface, or the GUI, which is the GUI. Instead of typing complex commands, you could uh, now click on icons, open windows, and interact visually with the computer, right? This made this made computers much easier to use and opened the door for more people to start using technology. Then came another major improvement, which is the wireless technology, right? With uh, with laptops and wireless connections, computers were no longer tied to one place, right? You could carry your systems anywhere. You could work while traveling, communicate with clients, and complete tasks from almost anywhere in the world. Like how you are taking your degrees from anywhere in the world. You can take your degree. You just open your laptop, you enter the internet, take your degree, and you do your studies and everything, right? Complete all your tasks on the internet, right? So another big shift was cost, right? The cost of it was another big shift, right? So computers and then internet access became much more affordable. And because of that, technology spread to a much wider group, right, of people. No longer just big companies or experts, right? Now, everyday people could use computers, right? Today, information technology affects almost every part of our lives, from business to education to government, right? And even our daily activities. our daily activities. With the rise of smartphone and then widespread internet access, technology is now in our hands literally. People across the world can now connect instantly, right? And share information and access the service from anywhere. There was once an idea called the information superhighway. That idea is the idea that communication, entertainment, and technology will all come together into one system, right? And today, that idea is no longer a concept. It is a reality. Your smartphone does all of that in one place, right? They are now a basic part of everyday life, right? They are now part of our everyday life. What was once limited to experts is now something everyone can use, right? And that's why learning computer science is so important today, right? And so this will be the end of our history into from the beginning of how everything started and all, right? So we will end it here. Our next topic, we will look into data processing and information, right? So see you in the next video. If you enjoy the video, if you like the video, make sure to subscribe to this channel, and let's learn computer science together.